Hi, everyone.
Yeah.
Welcome. Today, I have a special guest with me, JK. Now, today, I'm going to talk about a really interesting topic, and it was triggered by something that Andre Karpathy had said recently at a Y Combinator event. And what he spoke about was about the future of computing, and he raised some really interesting topics. So I thought I'd bring an expert on to discuss these topics. I've brought on JK. Welcome.
Hello.
I was going to ask JK, maybe give the folks a little bit of background, and because you've been in AI and machine learning for quite a few years.
I've been in AI like about 2010s since uni, and it was really great to see everything develop. Like when we were in uni, we learned a lot of algorithms that are taught today, but we never actually understood quite how impactful they are. And now looking back, it's like really incredible to see how far we came. And also what is very interesting is I actually tried to make a thesis about ambient intelligence, and at Google I/O now they're starting to talk about ambient intelligence, where intelligence actually disappears into the background and you don't even see what's going on. You're just like it's like an action and reaction rather than you actively working with AI, and that can result in some very interesting cases.
So there used to be an old saying that if you kept your clothes for a long, long time, they'd finally come back into fashion. And it seems that something you've been studying for 15 odd years. It's funny because I have listened to a bunch of people on YouTube and podcasts that have been in AI for many, many years, and they said that it was very hidden for a long, long time, and it was being used. But this thing that Andre Karpathy spoke about, let's sort of dive in, because some of the things he discussed, he discussed the concept of what he called software 1.0, which is this sort of manually written code. Now, JK and I work in a software consultancy, and we're sort of a deep engineering firm, and we do a lot of software. But software 1.0 was a lot of manually written rules in code. If this, do that. If this doesn't happen, do that. And that's what he calls software 1.0. What he talks about is the concept of software 2.0 and the concept of software 3.0. So he spoke about software 2.0, which I'm sure you can talk to because this is where you got trained, which is neural networks. So sort of talk about software 2.0.
Yeah, I think you can look at this from very different perspectives. Like if you look from user interface, there's going to be different .0 versions than, for instance, how the application thinks and executes actions. And I think what we're talking about here is how we actually execute something. Like we have an idea, we have an spec, how do we get the machine to execute it? And I think this is where we're going to 3.0, is in execution of those actions. So, as I said, we started off with writing lots of e-statements. We needed to gather all of these specs from the client and convert it into code, essentially, with an user interface where people can put in the data, and then we process that and something happens. Usually in the database, we get stuff in and send an email or things like that. Then what we were starting to do, and where we kind of are now, but we already dipping into software 3.0, is if you already have all of the data, you can train a custom machine learning to figure out the rules on its own. So as things change over time, it can adapt, and you can and if you train it well, you can actually see those changes over time. This takes a lot of training. it's possible to make it reactive so that it learns as it goes, but usually you need to retrain the whole thing. But if you have enough resources, enough engineers, you can actually make it like incremental learning.
Interesting.
You can look at this like the YouTube algorithms, Google search rankings and stuff like that.
So he spoke to a concept, and maybe you could help clear it up for myself and others. Is that in version 2.0 is that the way software is written is using a thing they call weights. Now, we all hear what it means. Try to explain for the layperson, what do they mean by weights? Because you don't do ifs and then because that's software 1.0, but software 2.0 is weights. Talk about how does that sort of work?
So you can think of the neural network as a very complicated decision tree. But that decision tree has more than one entry point, which is why it makes it so difficult to debug, because you're no longer just having one linear path that splits off into different directions. You have multiple parallel lines that impact each other. And that's what it basically means is each decision has a weight. Like if you get, say, two inputs, one is a 1 and the other one is a 0, the weight can be what happens. Should it pass through a 1? Should it pass through a 0? Should it be 0.5? And things like that. And then there's that fine tuning. Basically, how do you react to input in each of the nodes? It's almost like how our brains, the neurons only activate, for instance, if a signal goes through, but it only for a specific signal. It could be connected to millions of signals, but it pushes forward its own signal only when it gets certain signals.
So is another way of looking at it that a thing or a judgment or a piece of code puts a number on a thing. So a word, let's just say that I'm trying to think of an example. So
maybe a simple example.
This thing this person did is not very nice. Give that a rating of, let's say, a 2. And let's say, no, the person the thing did is bad. And the bad is a little bit heavier weights than the word not very nice. So we'd give that a 5. And then we say the thing that the person did was absolutely horrible. And we give that a weight of 10. Is that sort of a way of thinking about it?
Yes, that's how you can think about it. But a simpler example might be, for instance, you're doing insurance, right? Yeah. And perhaps some of the parameters of the insurance would be age. It could be the income and things like that. And imagine that the age would be from 0 to 1, where 0 is 0 age, 1 would be, say, 150 years. And then say, or to simplify it, let's say that's 100 years. And say that the neuron only activates if the value that comes into it is between 0.2 and, say, 0.5. So between 20 and 50 years. Right. So this kind of a thing. And we're just tweaking that one little weight to then decide when that gets triggered. But the thing is, with machine learning, that training is done for us. And for instance, if age does not matter, it may not even be part of the machine learning algorithm. The neural network, because it just optimized it out of the neural networks. So that's one very interesting thing and one of the reasons why some sometimes we struggle to fully understand what happened is because every single time we retrain a model, the decision tree ends up being different. It might have similar comparisons than the previous one, but it might be in a completely different place in a complete, and the path to get to it might be completely different than previously, but it might actually function exactly the same as before.
Interesting, and obviously he then talks about sort of software 2.0 is this weights. Then he talks about software 3.0, which is that where computers will be programmed using natural language, where we can speak to the computer and it will produce something for us. Without having to do any of this stuff, it'll actually produce anything we want. What do you think about that?
So there's an interesting problem with software 2.0 is consistency and visibility. But what software 3.0 is trying to achieve, and what we're seeing with vibe coding and things like that, is we actually have now a human-readable code. Now, it may generate thousands of files, and you can argue that it's not readable because too much of it, but everything is readable. Everything you can review and compile it down into a predictable software because it is software 1.0, but generated by the AI. And that AI can have all of the knowledge, that we needed to generate 2.0, and then convert it into actual code that allows us to execute the actions. For instance, if we do an insurance policy, for instance, we could have an actual if statements back again, where it clearly says if that the user has to be in that date range, and then that becomes very readable. And if there's any bugs, you can easily fix it as well. Whereas if you have a machine learning model, good luck finding the neuron that is wrong.
Well, okay, so that sort of dovetails in a couple of other problems he sees. So he puts a couple other sort of key theses forward. So obviously software 1, 2, and 3, and how that sort of we're in the middle of that evolution as we speak. But he also talks to a couple other things that that are especially challenges today. And someone who, well, I vibe code, yes, I do, and I am building more software than I've ever built in my whole entire life, and workflows and all this sort of stuff. But one thing he talks to, which is a problem, and I'm finding a problem, is this persistent memory, where you continually have got to give the large language model all this context and all this sort of stuff. And if you hire an employee, which is what happens when you're a human, is experience means that you don't have to explain every single thing. So someone who's like myself, who's got a few grey hairs, if I've been somewhere for a while, I've got a lot of experience. And if I have to, give a large language model all that context, it's a really challenging problem. And he said that that's still a big problem in AI as it evolves. And he said that that's still a problem that many are facing. Are you seeing the same problems?
Yeah, and I see this being solved in multiple ways. Like, for instance, ChatGPT has the O3 thinking model, which seems to be drawing not just from the memories that it creates, but also from the previous chats that you had with it. But it takes longer to do all of the operations and things like that. It's the primary concern for cloud LLMs in perspective of memory is you either go in the direction where all of the operation takes a long time because it needs to go through the memory, figure out if any memory is relevant and stuff like that, or you go into the direction where you actually do some additional training, or you add some additional layers to it to kind of almost baked in into the model to be able to access that data, or essentially, when you have a prompt, try have an additional process that adds in additional context before
Yeah.
it goes into main processing.
Yeah.
But
But
there
that's
is
still
another.
like I know from all levels of people that we speak to with regards to AI is getting the most out of it is very much how much you feed that. And it can be with big complex, especially big code bases and where the software gets complex. That's where, because like I always laugh, the developers that I talk to who do big complex projects, they say that vibe coding is great, but all you see on the internet is people doing a one-page website with some pretty pictures on it. I've never seen anybody do anything with any great complexity because it just can't ingest all that context. Yeah. Anyway, so a couple of other things that he spoke to, which I thought was another really interesting point. He spoke about that large language models and these AIs are the operating system of the future. And rather than being an app or thinking of them like an app, like, I don't know, an email app or, something that you would have on your phone or your PC, he says that they're going to start to be thought of as operating systems. And he draws a parallel between the old mainframes of many, many years ago, where to access computers, we used to have these thin clients, these really, really dumb computers that spoke back to a mainframe computer. And in effect, it's sort of true. And let me just recount a little story. I think it was last week. We're in the middle of June 2025 when this is being recorded, and I think about a week ago that ChatGPT went down for about 4.5 hours globally, and they said that the marketing teams everywhere couldn't push out all the dribble, and there were a whole bunch of people that couldn't write emails and all sorts of stuff like that. And it sort of pointed to that these, in such a short period of time, have become really reliant, but they're becoming more than just an app. They're becoming operating systems, and that we're now reverting back to what we were in the 70s, which is these thin clients, because all of the compute is in the cloud. Now, I've got a reasonably powerful laptop, but it can't run anywhere near the large language models that are in ChatGPT or Claude or Gemini. Do you see this evolving to the point where we're all going to be using these cloud-based systems and we're all going to have these dumb phones and dumb desktops because everything's going to be in the cloud?
I see that we're going to develop, at least for the next couple of years, in parallel, both directions, where we're going to have more and more stuff on the cloud and what they call ambient intelligence. We have more and more AIs, even the ones that we don't see. And more people will rely on that for things that really needs powerful AIs. But what I also see is that AI won't be able to scale as fast as we want to consume it. Just think about how much power, energy issues we might have if everyone starts to use AI. And this is
That's a big
where
restrict.
smaller devices, our phones, our tablets, our laptops, and in the future, even potentially our TVs, Wi-Fi routers, and other devices that, most of the time, they won't do much things, so they could do process things in the background. They're going to use very small LLMs, like, for example, something that kind of can compete against ChatGPT 3.5 now can run on with just 10 watts of power, which is basically, from what I measured at my home, is like 2 idle laptops or 2 idle desktops, not running, just being plugged in power in sleep, which is very little, all things considered.
Yeah. And then we'll have them on devices, like these little AI large language models that'll run on your phone and on devices
Yeah,
in your fridge.
and yeah. And one very interesting thing that I hope that we're going to go into the direction is a lot of people right now scared for privacy, and that currently drives the development of local AIs. And what I see is that rather than having a Jarvis that is available for everyone from one local farm server from cloud provider, I see that we would rather have a Jarvis in our homes that have very limited access to the internet and runs within our network, and a Jarvis for Office that with the data, sensitive data is consolidated inside the network, doesn't go outside. So it's safer from the privacy perspective. And also, what we can do is we can have an AI that has very good understanding of what you're trying to achieve, which nowadays we can use fairly small LLM models to achieve that, and they're pretty decent at figuring out what you're trying to achieve. And then we would have a network of agents, which could potentially be, say, your fridge or your TV or your robot cleaner, or maybe you have a Mac Mini running your own LLM on it, a bit larger one, and then this smaller LLM, this central intelligence, can then say, "Hey, I have this." The user asked me this task. I can't do this on my own, but that agent can. So I'm pushing that information to that agent to do that work. And having really specialized AIs allows us to have much smaller footprint in terms of size, the hardware that we need, and also power consumption, because now we no longer need to have one AI that solves everything. Now we could have very specialized AIs that can just solve those couple of things, but still understand, human language and stuff like that.
So I mean, it dovetails into another big topic of this year, and many people talk about this, which is the world of agents. And Andre's sort of broad thesis is these things will become more and more agentic, or take more and more agency. So what that would mean in a practical sense is that rather than them being part of a workflow where they do a very small task, is you may have one AI that sits above it with the goal. Let's say that the goal is to make sure that you wear clean clothes. And so that may be a small little LLM that runs on the washing machine to make, because you go to the gym and it knows how to wash these clothes rather than those clothes. It reminds you when to wash your stuff. It knows all this sort of stuff. But the orchestrator, the thing that sits above it, is the thing that they believe is going to take more and more agency and do things on its own, make decisions on its own. And then with these smaller large language models, they're going to start to do stuff. That's an interesting world, isn't it? Do you see that you will be giving agency to large language models and agents that you would build?
Yes, but mostly local ones. And I actually got myself, and I'm waiting for my Mac Mini. I got a 32 gigabyte version just so that I can run a bigger LLM model. And the surprising thing is, like, for 45 watts, I think it's even 20 watts, you can run pretty big models and really powerful AI, which is insane to think about. That was like 200 watts minimum last year. But what I'm seeing is, in 2010, I was planning about building intelligence that looks at my calendar and tells me, "Hey, you have an event say, an hour drive away, and it's about an hour and a half, here's your half an hour warning that you should start driving in an hour,
Right.
that you need to drive in half an hour because you need an hour to reach there. So you have an
Yeah.
hour and a half warning, whereas by default in your calendar, you can have only half an hour, an hour. Doesn't really take into consideration the distance that you need to cover. But
Right.
now what I'm thinking is I can build a agent that I don't have to think about, all of the possible events that are happening in my area. I'm just like, hey, what could I do, say, this evening in 2 hours? And the AI says like, okay, you finish at work about 6 p.m. And say that you don't want to walk more than 15 minutes. Here are all of the events, narrows down to your preferences and stuff like that, and says, here's two good options for you. And this is something you really want to do safe on local LLM, because you don't really want the big LLMs to learn too much about you. But
Yes.
what it also allows you to do is refocus where your focus is, essentially. Like, for
Yeah. Right.
instance, I do want to connect to people, I want to socialize more and things like that, for instance.
Yep.
But I don't have to spend, hours scouring all the internet to find those locations. I can write AI that does that for me. And we can look at the central intelligence at home. Say, for instance, it notices that some of the devices are consuming more power than usual, and they can do diagnostics for us. They might see that, for instance, the apartment is cooler than usual. Maybe the AC is going bad, or the user is not at home. And also, in the future, what we can have is more interconnected devices where, for instance, you do some cooking, you make a bit of a mess, you need to rush out, and the AI could figure out, okay, maybe we should turn on the robot cleaner
Yep.
so that the apartment is clean by the time I'm back. Things like that. Like, we
I've got a
can
robo
add
cleaner,
a lot of
and
that.
it's very narrowly smart, meaning it. But we've got one of these chairs that has got a sort of an angled leg, and
Yeah.
every other day it gets stuck on this angled leg, and then it's sort of smart with a very small s. So there's still a lot of room for improvement for this local stuff, and the world of agents. And what I say is that I see it being good, and I mean everything that Andre Karpathy says, but everything that I witness in a day to day, which is I work with solution architects like yourself on big corporate projects, and we look at, and I've done vibe coding, and I've built agents myself, and I see that the talk in the media and the headlines sort of is a little bit ahead of capability right now in the real world. And I see a lot of people still struggling how to place it, because the media, it's the second coming, and we all, and anyone's, either it's going to be from one side of the world, which is that everyone will have this abundance and it will be fabulous, to AI is going to be the end of humanity. And I've heard opinions on both sides, whereas in reality, where I suppose you and I sit at JK, because we're sort of at different parts of that whole very complex software business, it's got some power, but it's still got some big limitations. Would you agree?
Yes, and I think if anyone wants to understand the impact, just think about what you were doing before the smartphones came out. Like, I think
Like
this
Berry.
is right about the scale of, before the smartphones, before laptops, you can bring laptop everywhere. It's this kind of impact that we're looking for. Now, we didn't suddenly everyone lose the jobs and everything like that. There was a big shift, don't get me wrong, but I think we are looking something more similar to that. It's more of a transformation of how we work, how we think about day-to-day things. Like, just think about before you had phones, you had to write down everything. You have
Yep.
to confirm with everyone, is this what you need me to buy? Because once I'm off, you won't be able to call me. You won't
Yeah,
be able
yeah,
to
yeah.
reach me
Well,
because back then we didn't have phones.
well, and interestingly enough, is that in 2000, if you'd said to me that someone doing YouTube was a full time job, and his point, right to your point, is in my local shopping centre there are two computer stores, and one of their primary sources of income is replacing the glass on smartphone screens. And that wasn't was not only not a profession, it was not a business 15 years ago. So if someone said, yeah, I'm going to replace screens on smartphones, they go, what's a smartphone? What's a screen? And to say that there are two businesses, there's two nail shops and two smartphone replacement businesses. They're really small businesses in my local shopping centre. I'm going, okay, so this is how technology changes, but there's people with jobs. So as some people see all this change going to happen, there are a lot of things that we can't even imagine, I'm guessing. So yeah, I see it on the ground,
Yeah.
and I listen to Andre, but from where you and I sit on, because we build these big complex systems for clients, there's a lot of potential, but there's still a lot of problems that got to be worked out, in my view.
Yeah. And, to come back to one of the things that you mentioned is we still have nail salons. Like, there's a lot of things that we don't think about that will still remain until we have robots that kind of replace them. But
Yeah, I
this
know.
is, I think, I'm more worried about, for instance, once we have really human-like robots when they can do actions like humans, because that is far more transformative in sense of what's going to happen with our jobs than AI. Although there
Yeah,
is something to be said for jobs that are highly bureaucratic,
yeah,
because they can be very much automated.
yeah,
So yeah, if the jobs that are highly bureaucratic, those ones are going to be problematic, potentially. But for instance, jobs that needs to think a lot, that needs to plan a lot, even though machines can do all of that, and let's say that they can do it better than us, there still needs to be a lot of communication between people,
mm,
because AI won't never be able to get all of the context that we need, because we don't get all of the context we need. Nobody has the full context that we need. And there's a
yeah,
lot of conversations going on in order to build that up, that context. And we're far from a time where we would feel comfortable to talk to an AI for 8 hours so that we can build up context. We're more comfortable to talk with various different people and do things in chunks, do work and things like that.
yep.
But hopefully that means that we will need to work less in the future. Fingers crossed. Let's make AI work for us, not
Well,
us
as
working for the
my
AI.
yeah, well, my experience has been is that in over the last 30 years, because I've been in technology for a long, long time, is that as the technology has increased, the demand for our labour to sort things out has just increased. And I know a lot of people that is working as many hours now as they ever have. I look at my parents in the 70s, was 9 to 5 jobs, and you didn't bring your work or your email or your anything home with you. You weren't next to a corded phone. You couldn't be contacted. So yeah, the world has changed. But back to Andre Karpathy's sort of discussion. It's interesting because he puts forward these things about how computing software is evolving. I think that regardless of what's coming in the future for our jobs and all of that sort of stuff, I think that at the heart of what he's talking about, it is right. There is going to be these fundamental changes in computing and software generally. It's my experience that still, regardless of how good you can think you can vibe code, complex systems still need experts at this point in time. I know you, JK, you're a solution architect, and you're asked to architect some pretty complex systems. And regardless of the vibe coding, you still need to nut stuff out yourself.
Yeah.
Yeah.
Like the way I'm looking things is, if we look at Star Trek and a lot of other series where you have AI that far eclipse what we have, but it's still the humans that make decisions. It's whatever sentient creatures are in that universe. But the way I'm trying to, get this back into the real world is oftentimes the best solutions are not necessary. And
No.
AI might be very good at finding the very best possible solution. But we really, most of the time, need just good enough. And sometimes you need a human to say, I know all of this is best practices and all of that stuff, for instance, but, we just need this.
Yeah.
This is all we need. We need to make this work really well. Just do that one thing. And I think that is one of the major problems right now we have, is because on one hand, either the AI goes way too simple solution, breaks the moment you're trying to add too much to it, or it tries to over-engineer the thing. It's super maintainable and stuff like that, but then it's too big for it to actually continue working on it because the context is too big. And it becomes also too large for a human to just jump in and fix things. And I think people are really good at just being at that middle where it's good enough that it works for what we need, and we can extend it to be better in the future, but also have enough thought behind it that it doesn't fall over for things that may happen.
Yes, I agree with you. Yeah, it's interesting. All right, well, let's wrap it up there. So thanks a lot, JK. So if you guys want to check it out, Andre Karpathy did I think a talk for Y Combinator, I think it was. You can see that on YouTube. He raises some interesting points. We discussed them today, and we have an expert on the call, Mr. JK, who's been doing AI and machine learning for 15 odd years, and as we discussed, it's pretty interesting that there's still a fair bit of devil in the detail before the Terminator's walking down the street and taking over our jobs. And look, I say it in a lot of the videos I do about what predictions of the future are like. Nobody knows. And as I said, in 2000, to think that I could walk into a shopping center and see two businesses that actually replace iPhone screens, that was not even a thing. So who knows what the jobs of the future will be. Thanks again, JK, for joining me.
Yeah, and besides, we might still have nail salons.
Yeah, exactly. Well, that's what he. Someone asked. I think was it one of the. I think it was not Sam Altman. Anyway, it was one of the AI power US heads of one of the. And he says, "What would you tell your children if you were going to give career advice?" He said, "Be a plumber or be a nails technician." Because that's not being replaced by AI anytime soon. But as we see, neither is high-level software programmers right now. They're the complex stuff that still needs us humans. But who knows in the future? Thanks, JK, for joining me.
Thanks for having me.